Hello, 5th grade. I hope that this video finds you well. Today we're going to start talking about chemical reactions, and specifically we're going to talk about one kind of chemical reaction called a synthesis reaction. So let's get into it here. Now, first off, we need to talk about what a chemical reaction actually is. A chemical reaction is a process in which substances, which are called reactants, are converted into other substances, which are called products. So you start with these substances, and they're called reactants, and they can be any chemical, and you get products, which could also be just about any chemical. So you start with a substance, and you get a different substance at the end. So a way to remember the words reactants and products is the reactants are the things that react with each other, and the products are the things that are produced at the end. So you go from your reactants to your products. So, you should know the basic form of a chemical equation. Kind of like you have an equation in math, you have equations in chemistry as well. But instead of an equals sign in the middle, you have an arrow. And the arrow usually points to the right. So you're going to have your reactants on the left, the things you start with, and then an arrow pointing to your products, and those are the things that you end with. So say you're combining substance A and substance B, and you're getting substance C. You're going to have A plus B, and then the arrow, and then a C. So your reactants are giving you your products there. Now, there are actually a lot of different kinds of chemical reactions out there. We have synthesis and decomposition, and single displacement, and double displacement, and combustion. But right now, we're just going to focus on synthesis reactions. We might get into a couple of these others here in the next few lessons. But for right now, we're just going to look at synthesis reactions. Now, in a synthesis reaction, you're basically just building something out of two starting materials, or more starting materials possibly. So you're synthesizing something new. So our definition is going to be it's multiple reactants joining together to form a single product. So you have multiple reactants, and they're forming a single product. So in this case, I have just an example, and A and B here aren't real elements. This isn't a real chemical formula. A and B just stand for other molecules that could be put in there. So we'd have A plus B, arrow, AB. So A and B are just getting stuck together, and you're getting AB. And you can actually see it represented down on the very bottom. You have an A atom plus a B atom, and then the A and B get stuck together with a chemical bond. So they're actually a single molecule there at the end, and that is AB. So let's do a couple examples of synthesis reactions so you can see how this works. The first one here is Zn, which is zinc, plus I, which is iodine, and it's giving us Zni, which is zinc iodine, which is zinc and iodine just stuck together. So Zn plus I, arrow, Zni. It seems simple enough, right? You just smash the letters together and you win. So let's look at another one. Na plus Cl, arrow, NaCl. Now, this is a good test of your how you're doing on memorizing your different chemical symbols. Na is sodium, and Cl is chlorine. So Na plus Cl, sodium plus chlorine, gives you sodium chloride. Now, fun fact about this real quick before we go on. Sodium is a metal that is extremely reactive when it's in its raw sodium form. If you were to drop a chunk of sodium into water, it actually will react with it and kind of like do an explodey, fiery sort of thingy. So it's explosive when it hits water. And chlorine naturally exists as a gas, and it is a poisonous gas. So when you combine this explosive metal plus this poisonous gas, you get sodium chloride, which is table salt. When you have chemicals changing their molecular structure, they can have completely different properties. So when you're eating sodium chloride, that is table salt, which you do every day, I'm sure, you can think of it, you're actually eating an explosive metal and a deadly gas. They're just combined together in a nice, harmless way. Now, I want to focus on the second equation here. Sodium plus chlorine gives you sodium chloride a little bit, because this is where synthesis reactions are going to get a little bit trickier than just smashing the letters together. So it's going to be a little more involved in that, and there's this thing called balancing chemical equations that you're going to need to know how to do. And that's actually going to be the rest of our lesson, is balancing chemical equations. So if we look at this sodium plus chlorine, giving you sodium chloride, I will represent this equation with a picture. So the red circle here is a sodium atom, the blue circle here is a chlorine atom, and when you add them together, you get sodium chloride. Notice how they're stuck together here on the right side of the arrow, because that is our product and it's a synthesis reaction. But the problem is that chlorine, you don't really find chlorine atoms just hanging out all by themselves out in nature. They're always kind of joined with another chlorine atom. They like to have a buddy system, and this is called a diatomic molecule. Diatomic means two atoms, so chlorine always exists with another chlorine. So whenever you find one chlorine, you're going to see another one hanging out with it. So the problem here is, if this is an equation, we want it to be balanced, right? But I see one red circle on the left side, one red circle on the right side, but I see two blue circles on the left side of this arrow, and one blue circle on the right side of this arrow. And that's problematic because it's not balanced then. Anything you have on one side of the arrow, you have to have on the other side of the arrow. Just like in math, if you had 2 plus 2 equals 5, that doesn't work, because on the one side you have them adding to 4, on the other side you have them adding to, you have 5, so it's an imbalanced equation. It's not true. So here we can't have you can't have two chlorines giving you a single chlorine. Like, where's that other chlorine going? We need to know that. We have to understand what's going on here. So this is where, remember a few lessons ago when I taught you how to write those numbers into chemical formulas, that's where this is going to come in. We add numbers to the equation to make it so it's balanced. Before I go there, if we have two chlorine atoms on the left-hand side, we need to find out some way to get two chlorine atoms on the right side of the arrow. And a simple way to do that here would be just to throw in another sodium chloride, because we know our product is sodium chloride. So if we have two chlorines over here, that means we must have another sodium chloride over on the right-hand side, and that's where that other chlorine is. So now we have both chlorines accounted for. One chlorine here, actually two chlorines on the left side, two chlorines on the right side, and two different sodium chloride atoms. But then, those of you who are keen might notice that there is another problem that just came up, and that is that we have two sodium atoms, the red circles, on the right side of the equation, and only one on the left side of the equation. So we have to find some way to make that balanced now. And the simple way to do this is just to add another sodium atom on the left side of the equation. So our solution is to add another sodium over here and have another sodium chloride over on the right-hand side, and then we rewrite our equation after we have that figured out. So we're going to rewrite this by adding in those numbers. So because I have two separate sodium atoms, I'm going to have 2 Na, which is 2 sodiums, plus, and you might be tempted to say 2 Cl's, but because they're stuck in one molecule like this, it's going to be Cl2, because it's just one molecule of two chlorines. So it's 2 Na plus Cl2, and that's giving us 2 sodium chloride atoms, so 2 NaCl. And you can do a little count here to make sure we have all the atoms accounted for. On the left-hand side, we have 2 sodiums. On the right-hand side, we have 2 sodiums. On the left-hand side, we have 2 chlorines. On the right-hand side, we have 2 chlorines. Remember, when a number comes in front of a molecule, it applies to the whole molecule. So you have 2 sodium chlorides. So that's how we balance chemical equations. You just have to add the numbers to make everything balanced, and you keep adding them until it works. And hopefully it will work. I won't give you any that don't work. So let's practice balancing another one. Here we are adding hydrogen, H2, plus oxygen, O2, and we're making H2O, which is just water. And hydrogen and oxygen are both diatomic elements as well, so they like to do the buddy system, where when you have one hydrogen, you're going to have another hydrogen, and where you have one oxygen, you're going to have it bonded to another oxygen. It's just the way that they like to exist. So I'm going to also represent this with the nice little ovals. Let me get my video out of here for a little bit. So we have here an equation, H2 plus O2 is giving you H2O. And so we have our H's represented with little green circles, and our O's represented with yellow circles, and you might notice that this equation is not balanced. We have 2 hydrogens on the left and 2 hydrogens on the right. That makes sense, it works out. But when we look at the yellow oxygens, we have 2 on the left but only 1 on the right. And that's going to be a problem because we want it to be balanced. Also, just for the record, this is the shape of a water molecule, and there's a whole lot of fun studies we could do on that, but I just wanted to point out it looks kind of like Mickey Mouse. So that's a way to remember what water looks like. You have an oxygen in the middle with 2 hydrogens as the Mickey Mouse ears. If I were to turn it upside down, it would especially look like Mickey Mouse. But anyways, so we need to go ahead and balance this equation. And kind of like we did for the sodium chloride, the solution I think that we could start by approaching is say, well, if we have 2 oxygens over here and only 1 over here in this H2O, why not add another H2O so that we have 2 oxygens over on the right-hand side? And so we will go ahead and do that. We will, let's see, my slideshow comes, there it is. We'll add a 2 in front of that H2O to make it so we have 2 water molecules. And then our diagram would look something like this. And now we have 2 yellow on the left, 2 yellow on the right, 2 green on the left, but oh no, there are 4 greens on the right now. We have 4 hydrogen atoms over on the right-hand side. And so what we have to do now is find a way to balance that out. And it seems simple enough. If we have 4 over here and 2 over here, all we have to do is add another 2 to the left-hand side, and we should be good to go. So if we make it 2H2 plus O2, giving 2H2O, that should check out. Because I see 4 hydrogens over here on the left, 4 hydrogens on the right, 2 oxygens on the left, and because this 2 is out in front of the H2O, there's 2 oxygens on the right-hand side of this equation as well. So when we look at the diagram, we can check the box that it does work. We have 4 green on each side and 2 yellow on each side. So this equation is balanced now. So what I would like you guys to do is practice balancing equations a little bit and filling in blanks for chemical reactions. These are just 4 problems. I'm hoping it won't take you too long, and I will give you the answers at a later time, not right now. But I would like you to go ahead and try to either, for numbers 1 and 2, fill in the missing molecule, the thing that's missing, to complete the synthesis reaction. And then in numbers 3 and 4, you're going to be adding in numbers before these molecules to balance the equations. So you have to look at what you know and then figure out what else has to be the case based on the numbers that you know. And we can go through these another time now, give you the answers. So you can go ahead and pause the video and just see if you can work these out and maybe a scratch piece of paper or in your notebooks if you have them. And I will give you the answers at another time. Well, I hope you enjoyed this introduction to chemical reactions. There's a lot of fun stuff you can do with chemical reactions, and we're just getting started. So I hope that you all have a great spring break and a very happy Easter. Take care, everybody.